very good morning, good afternoon, good evening to all of you, all the participants. And as you know, this is a MOOC NPTEL course, and the title of the course is Application of Forecasting, Regression and Time Series Models. And my good name, as you can see in the slides, I am Raghunandan Sengupta from the IME department at IIT Kanpur. Now, all of you would have gone through the short video for this course, which is being floated for the first time. So, I will give you few details, even though it is a repetition, please excuse me. So, this is a course which will cover three broad topics. So, the topics are forecasting, different concepts of forecasting. So, that can be in the area of simple average, exponential smoothing, weighted average, then adjusted parameters being done for forecasting, for multi-parameters, for single parameters. Then we will do the halt linear method for forecasting. Then we will do the halt winter method for both for additive and multiplicative models, and we will understand them in details, do simple examples. There will be other topics also. So, the other second part of this course is in the area of, as you can see, regression models. Main focus will be multiple linear regression, but we will also try to basically cover other relevant topics as applicable for different type of time series data. Now, I am using the word time series here, but the main information for the regression model would be you want to regress or utilize the information for set of independent variables to forecast, predict, whatever the word you use, to find out the dependent variable. And there are many techniques for that, and also we will cover that with examples. The third big topic would be the area in the area of time series. So, it will cover the concept of ARIMA models, ARCH models, CARCH models and other time series techniques. Now, for this whole course, we would like to keep theory to the minimum level. There would not be any proofs. You are not required to solve the proofs. Let me make it very clear, not solve the proofs, because they would not be covered either in the assignments or in the final examination. But the applications of the theory would be applied. So, considering that some background is needed, how you utilize these models, why you utilize the models, what are conditions, what are the assumptions when you utilize the models, that I thought would be necessary, such that the interest for the different topics would be much more for the candidates and participants who will be doing this course. The other thing is that this course is basically for 30 hours, each week 5 lectures, each lecture 30 minutes. And after 5 days of classes in a week, you will have an assignment. So, technically there would be 12 assignments. Each assignment would have maximum of 10 questions. They would be directly from the assignments. It will be either MCQ with one answer correct and the options being A, B, C, D, E, 5 options, only one correct, there is no negative marking. And these MCQ questions can be either qualitative or quantitative. Qualitative in the sense some concept and you have to find out the right word or the concepts. True and false depending on the statement, and quantitative would be a simple problem given, you have to solve it. And the final examination would be of 50 questions, each of 2 marks, there is no negative mark, and also the division of these 50 questions would be based on the fact they would be true and false, they would be MCQ, multiple choice questions with the quantitative or the qualitative part. no negative marking for any of the questions. In MCQs, there will be 5 options, only one is correct. The other part, few questions would be there in the final questions would be range based, that depending range obviously would mean that there are quantitative in nature. So, problem or the background of the problem is given and you have to find out the answer, and obviously depending on the assumptions you use, which will be made very clear because there should not be any ambiguity in the questions. You have to find out the answer, and obviously marks will be given depending on the answer being within a certain range. So, with this I will start the course. So, as I said, we will cover the concept of averaging techniques and forecasting. We will cover the concept of multiple linear regression or regression models. Some other topics will also be covered, we will come to that, and we will cover the concept of time series. Now, if you say that if the 60 hours lectures would be divided into proportions of 1/3, 1/3, 1/3 for these 3 topics, that would not be so, because technically average techniques and forecasting techniques has lot of concepts. So, the main stress would be there. Regression models are interesting. So, a little bit less, I will not use the word coverage, but the less amount of time will be spent because the ideas would be very simple. Time series may cover a little bit more in the same tune about for averaging techniques and forecasting, which we will be covering. So, the first set of discussions, as I said, would be in the area of averaging techniques and forecasting, and this is what we will start from this lecture, and this is week 1, lecture 1. So, obviously, as I said, each week we will have 5 lectures. So, this is the first lecture. Now, what is the coverage for this lecture? Even though the coverages has been stated here, depending on how the flow is, we would not be able to cover all the topics as written in the coverages. So, when we basically go to, say for example, for lecture 2, maybe some spillover which may have happened for lecture 1 for any week. So, it will be covered. So, it will be going to the next lecture. So, the slides which you see in the video and the slides will be shared with you, because all the slides will be shared. So, be aware that they would be divided into week wise in the final slides, because once the recording is over, I would understand what is the exact coverage. So, slides would be tailor-made exactly to the lecture for each week which is covered. So, do not be confused by that. So, even if you see the coverage as stated in slide number 5, so subsequently that may not exactly match with the slides which will be shared with all the students and through the NPTEL office. So, what is the coverage? We will consider different examples, and when you are doing the examples, I will discuss, and there are actually examples taken from practical information or information which is available. We will consider the concepts of different quantitative and qualitative techniques in forecasting. We will also understand what are the steps in forecasting. So, these are not sacrosanct fixed steps, they are the general flow how the forecasting techniques are done. What are the types of forecasting we will cover, and later on, as I said, we will discuss them in details. We will consider different type of numerical measures. So, what are the measures based on which you think your forecasting technique is good, or why would you say a forecasting technique is the best, considering different types of data can be available. It can be data related to production of fruit grains, it can be the data related to, say for example, rainfall, it can be data related to time series of financial values. Even the financial values or economic values would be more of an emphasis in the time series data, the third component of this MOOC lecture. So, data can be related to passengers traveling in international airlines through a particular airport, it can be related to amount of tonnage of goods passing through some canal. So, they are, and all the data which we will be utilizing are easily available in net. So, we will consider the what are the measures, different measures are there. Measures depending on how you want to find out the best model. So, obviously, the main idea would be to minimize the amount of error of forecasting. So, whatever the error can have different connotations. So, how you want to minimize the error? Error can be just a simple difference. Error can be just the mode of difference. Error can be, say for example, variability, variance, or some ratios. We will see that. And the next topic of coverage would be metric of forecasting, how the forecasting techniques are to be utilized depending on different examples which we cover slowly. Now, each examples would be numbered here. So, as we cover, so we will follow a sequence of numbering. So, it is not that for forecasting it will be numbered 1 to 20. Say for example, if there are 20 examples, so it will be continuous. So, the 21st one would basically start from the regression model. So, if the regression model examples end at 41st, so the 42nd example will basically from the time series. So, the logical flow is there. So, this is the information or the data which you see about the India's total rice production in 10,000 ton for the year 1949-50 financial year to 2021-22, and the data has been taken, if you see, which I will just mark here for your information, is basically being taken from the India stat data. You can get it. And if you see the x axis, we have the year, though this is given in year. So, the x axis of the time frame based on which you are trying to consider it can be anything. For this is production. So, for some other thing, depending on what you are measuring, it can be in months, others can be weeks, something can be days, some can be quarters, some can be decades accordingly. So, if I consider, my apologies, I just went to the. So, if you consider, so say for example, so on the y axis you have basically the rice production in 10,000 tons as measured. So, if you look at it, and obviously I am just highlighting this is the year. So, if you look at it, and I will, rather than solving, I will just basically point it out. So, if I will use a color, say for example, red here, because this is blue line. So, if you look at the data, so there is a increase from 1950 to 1990 approximately, and then I will use another coloring one. So, if you see from 1990 onwards to 2020, so the trend has increased. Trend means the average value. So, the word trend which you are hearing for the first time, so basically the trend is increasing. So, that is one information. So, we need to basically fit a model such that the model will be applicable for the first time frame from 1950 to 1990, and for the next time frame which is basically 1990 to 2020. That is point 1 of set of observation which we have. The next observation is, again I will try it using the same color as. So, if you see the variability of the data for the first time frame considering 1950 to 1990, the variability is there, there is definitely this variability, but that variability if compared with the time frame of 1990 to 2020 for the first half 1950 to 1990 is less. So, that is the basically the second set of observation. Now, a person can definitely opine, and rightly so, he or she can say that why not we go into more detail. So, if I use a different color, say for example, the violet one. So, the set of data from 1990 to about 2000 or 2005, the trend is the blue violet one which you see, this one which I am drawing, when compared to the trend for the time frame 2005 to 2020, there is a change. I will use, say for example, the orange one. So, this is increasing faster. So, if I break up 1990 to 2020, for the first about 12 years, 12 to 13 years, this is approximate which I have shown in the violet one, the average value is higher, number one. Average value is increasing at a fixed rate because it is constant here. But past 2002 till 2020, the variability has increased. The average one, which is the orange one which was utilizing, that has increased. So, trend has increased, rate of increase of the trend is fast higher and the variability is also higher. So, this 5 or 6 observations which we are stating for this is basically which can be fathomed very easily from the figure. Now, why did I spend so much time in trying to understand that this or draw deduction is that, so these what we are seeing in technically observation, whether we are able to predict and forecast to the maximum possible extent without any error using the forecasting techniques. That is basically the idea we are trying to propose in this course. The next data is basically the average monthly temperatures in Fahrenheit in New York Central Park, and again just for information, the data is available at this website, which is www.weather.gov, and in this is a table sort of thing. So, in the first one, when it was basically production for India food grains, it was a line graph. So, data is obviously available, I did not want to place that, I wanted to basically give you that information. Now, if I basically have the data related to the temperature, it is given in a tabular format. So, what is there in the first column? It is the year starting from 2010 to 2019, and the subsequent columns are the months starting from January, which I am highlighting in yellow, till the last one which is in December. And if I consider, so each row, so you have 2020, all the data starting from 32.5 till 32.8 is basically the temperature from January to December for that year 2020. Similarly, you have, I am just going to not read the data, but I am just going to mark. Similarly, you have for 2011, 2012, 2013, 2014, 2015, 2016, 2017, 2018 until 2019. And as usual, the second column, which is this one, which I will basically highlight using. So, all the data here are for January for all the years. Similarly, if I consider the last column, it is basically the temperature for all the years for the month of December. Now, I need to plot them, and this is what is to be illustrated in the next slide. So, given this data, immediately you cannot say. Obviously, you have to do some calculations. So, rather than doing the calculations, I thought the pictorial diagram would be much more useful for trying to gather some facts, garner some information, so that we are much well acquainted and confident to utilize the forecasting technique. So, this is the pictorial diagram of the monthly average temperature in Fahrenheit for New York Central Park for 2010 to 2019. And you see the year starting from 2010 till 2019 is given in the x axis each year, and the temperature in Fahrenheit is basically given in the y axis. So, this is in Fahrenheit. and this is the year. So, if I consider any one data for any 1 year, so obviously say for example, the maximum if I see for 2010 is basically this line, which I am going to utilize the color here, this one. So, this is 80 plus something value. So, let us check which is the data which is there in the table. So, if I consider for 2010, so the data which is there for which it is maximum is in July. So, the graph or the line graph which is drawn is basically for the month of July. Now, what does it give? So, it gives you that July temperature for New York Central Park or in that area is the maximum. And if you see, starting from 2010 to 2019, it is almost everywhere it is maximum. Obviously, if somebody is very nitty-gritty, wants to be very nitty-gritty and wants to pick up some information, obviously he or she can say, well, in this part which is in 2016, July temperature was not the highest. We will check that. Again in 2018, the July temperature is not the highest. We will check it. Now, if I go into the minimum one, which is the black line, this one. So, obviously, from 2010 till 2019, it is almost the minimum, except 2013, then in the year of 2016, then in the year of 2017, and so on and so forth. So, let us check for 2019 which was the minimum. So, we check 2019, the minimum value was basically for the month of January. So, January 32.5 is the least. So, the black line which you have is basically for the minimum. For just 1 minute, I may be wrong. So, my apologies, sorry. So, if I consider for 2019, the minimum value was yes, 32 point, yes, so it is fine. So, basically it is for January. So, if I consider for the month of another very interesting thing, for January temperature 2010 and 2019 is 32.5. For 2019, the minimum was 32.9. So, basically it is the year as shown. This is for the month of January. And similarly, all the data is given. Now, why did I draw it? So, obviously, you can find out that you can find out from this data tabular 1, you can find out for the year wise what is the average for each year. So, obviously, you will be taking the average along the row. So, when I talk about along the row for 2010, you have to add up for that year all the month values 32.5 which is for January till 32.8 which is for December, add them up and divide by 12, that will give you the average temperature. Similarly, you can find out the average temperature for 2011 till 2019, and from that you can basically understand whether the average temperature there is showing an increasing trend. That is point 1. Point 2, say for example, somebody may not be interested in the average trend or average value for year wise, but he or she is more interested to find out that what is the average temperature, has there been an increase, has there been a decrease in the temperature for the month wise. So, if I am talking about the month wise, so we will check that for January, for all the years, this is the temperature and what is the fluctuation. So, if I consider for January starting from 2010 to 2019, so the values are fluctuating with information set that in 2017 January temperature was 38. Similarly, if I consider for February, which is the third column, and if you notice it, the February temperature for 2010 was 33.1 and it goes on, and in 2019 it was 36.2. So, the maximum value which you are getting is basically for the 2018 year, which is 42. So, here immediately some information should be immediately available to all the set of people or the participants, that in 2017 the maximum was in January, the maximum was in 2017. If I consider the February temperature, it was maximum in 2018. Then if I consider that, and if I want to basically be sure that whether for year wise month temperatures for January and February are increasing, but if I consider the fourth column for March, April, May, June, that information may not be available immediately or it cannot be deduced immediately. So, from this data also you can find out what is the variability or the variance of the temperature. You can find out month wise, you can find year wise. So, depending on which way you are looking at the data, you can definitely have a lot of information as stated. So, with this I will close the first class for week 1 and continue discussing the examples. Obviously, we have not started solving the problem, but this was basically the idea which I wanted to give about how forecasting examples can be considered to understand or at least pictorially have a look at how the data is behaving, such that we are much more confident in trying to utilize the different type of models which are applicable. Thank you very much and have a nice day.